Hey everyone, welcome back to the channel. If you're into a data science and machine learning, you have probably encountered linear regression. But what happens when the relationship between your variables is not linear? Well, that's where polynomial regressions comes in. So polynomial regression is a type of regression where the model fits a polynomial curve to your data. This is useful when you want to capture non-linear relationship between the independent and dependent variable. So let me show you an example. Imagine you are trying to predict house prices based on the number of year of house has been built. A linear regression might give you a straight line, but maybe the price does not necessarily just linear. It might increase more sharply after a certain number of years. So in such cases, polynomial regression model can help us capture the curve and fit a better line to our data. So let's jump into some code and see how to implement polynomial regression in the Python using scikit-learn. All right, so make sure you have installed these libraries. And as I said, the linear regression model have the straight line, the polynomial have the curve. And this is because of the polynomials are like quadratic equation ax squared plus bx plus c, or the cubic, where there is a power to the variable, then it's it's mainly the you have a polynomial there, right? So make sure you have these libraries installed. So we'll use the NumPy for numerical operation, matplotlib for plotting, the scikit-learn for building our regression model. All right, let's get started. So first we'll import the necessary libraries. So let me run this cell. So NumPy for, as I said, for our manipulation. So now next we are creating some random data point for our independent variable x, and we are defining cubic relationship between x and y to simulate a non-linear scenario. Notice I have also added some noises to make the data more realistic. Let me run this, and let's plot our data to visualize the relationship. So we'll notice it's not a straight line but rather a curve, right? This is our data. As you can see, the point form a cubic curve, which is exactly what we are trying to capture with the polynomial regression. Now here's where the magic pick happens. So to model this nonlinear relationship, we'll use polynomial feature to transform the data before applying the linear regression. So we have to transform our data into. So we use the polynomial feature to transfer our data into polynomial feature of degree 3, which means we are essentially adding the x square and x cube terms to the model. So if you see, it contains the x square, and x cube. Now we'll fit the simple linear regression model into a transformed data. The linear regression model will now learn the best fit curve for the polynomial feature we have just created. Once we transformed our feature, we use linear regression from scikit-learn to fit our model. And now let's plot the predicted value along with our original data and see how well the polynomial regression fit the data. So if I run this, and as you can see, the polynomial regression line, the red curve is a polynomial regression model we just created, and it fits the data much better than the linear would have. So lastly, we'll evaluate the model by calculating the mean squared error, the MSE. Let me run this to see how well our model perform. So MSE will give us the idea of how far our predicted values are from the actual value. A lower MSE indicates a better fit. And there you have it. We have successfully applied the polynomial regression to model data by transferring our data into a higher degree polynomial feature, we were able to fit a much better curve to data than a simple linear foot. So here's a quick recap. We generated some data, transform it using the polynomial features, fit it a linear regression model, and visualize the result. So now you can use this approach to tackle the nonlinear relationship in your data set. Yep. If you found this video helpful, don't forget to give it thumbs up and subscribe to the channel. Thank you for watching, and I will see you in the next one.